Hi, welcome back, everyone. And it's Theri Niemier, and I wanted to spend my last session talking about soil. Soil is really the foundation of life, um, as we say on the title of this. I'm going to share my screen and walk you through a lesson that I do with my students, both my junior high students and my college students. And I start with this 9 minute, really well done segment on YouTube on the formation of soil. So I want to encourage you to watch this or use this. It's a great one for using in class too. It's a lot of information packed into 9 minutes. Which is what I like, but also why I like to take this extra time to move through it a little more slowly and talk more about it. So join me today for a lesson on soil. Some of us have gotten this in our past experience. Some of us are on farms and know a lot about this, but it really is where we can put a lot of focus on earth stewardship with our students and bring in environmental science and really the whole big connection between agriculture and the environment can be seen in learning about soil. So again, join me. So soil is made up of 5 basic ingredients: air, water, minerals, and organic matter. And this little slice of the pie called organic matter is where our biology lives. Soil, when we talk with soil scientists, there's a language for talking about soil, and it includes these 12 concepts. They're very interrelated, and I mean, they're of course unique, but also very interrelated, and they all are going to focus on what makes soil work, and especially how soil can hold nutrients. So let's just go through them real quickly. This is a great project with students of all ages, is just to learn about your soil structure. How much sand, clay, and silt do you have in your soil? It can be a simple experiment by going out with a canning jar and collecting a half a jar of soil in the top 3 to 6 inches, and filling it with water, a drop of, I use Dawn dish detergent, shaking it up and letting it settle, and then applying this chart to see, what kind of particles do you have what size particles do you have in your soil? It can tell you a lot about how it's going to support life. Soil structure refers to the arrangement of those soil particles and how and what size pores. It affects how water runs through. So pores are the space between particles. Bulk density refers to the compaction of soil, and we know that heavily compacted soil does not allow water to run through it. It also makes it hard for plants to grow. Roots don't move through it well either. Organic matter, as I said, it's that slice of the pie that is the biology of our soil, and that does some of the biggest work in our soil to bring fertility to our plants, to our environment, to ourselves. Color tells us a lot about water holding, about dark soil is usually our better soil, our organic matter. It's usually at the very top of our soil profile. Reds indicate, more clay. So there's a whole range of colors and what they mean. So our soil depth is also going to tell us what kind of life it supports. If we have no topsoil, we have no biology, no ability to break down minerals and make them available to our plants, no water holding capability. So soil depth is very important. Soil temperatures indicate also what kind of life it supports. And there are different things that affect temperatures, such as shading, sun exposure, So knowing your soil temperatures are going to help you decide on what things will and won't work in your soil. Drainage, again, how does water flow through? Odor often is an indicator, that kind of sulfury smell of waterlogged. Sometimes that means, we have, you know, uh, negative bacterias and microbiology. Permeability is that the rate at which water flows through, uh, which often depends on your soil structure, how much sand and silt and clay you have. And then lastly, available water capacity. So that refers to how much water our soil can hold. So knowing soil properties is good. It allows us to talk to each other in the same language, and it moves us up towards what soil functions. Well, I really like this definition of soil functions from the World Soil Information Network. And essentially the first sentence: soil is our life support system. It provides the anchorage of roots that holds water and nutrients. Soils are home to microorganisms, thousands of pounds of microorganisms that cycle carbon, that cycle nitrogen, that support biology, including that larger biology that we see, and then also the plants grown in the soil support the even larger biology above the ground. So we build on soil as well as with it and in it. And it is the key to our food, energy, and water security. Soil testing is a great thing to do with your students. It's a great way to learn more about soil and all these different properties. Thing to remember is that when we're testing for biology, which is so important to regenerative agriculture, we're testing in the top 3 inches. When we're looking at mineral contents, we want to get a little deeper, and we want to look at a number of different things in these soil tests. It's not just minerals anymore. One time, farming just looked at the mineral content, but we've learned so much about not only the mineral content, but the biological communities that are in soil, but also the relationships between them. So the first thing we usually think of are our minerals present, and typically most soil has a lot of mineral content. It's about, can we get those minerals soluble so that our plants, our microorganisms, are they present so that they can break it down and make these minerals available to plants, and then of course available to us, because that's truly what nutrition is. Knowing how acidic our soil is, which is done through the pH testing, the power of hydrogen. Some plants, instead of trying to change our soil, looking at the plants that will do well with the soil that you have is always a better way of working with nature. Cation exchange, I think this is one of the harder concepts for kids, for young adults even. But essentially what it means is, how much clay do we have in our soil? Clay holds so much nutrients, but if you have too much of it, it's the smallest particles. They are going to stick together, be rather compacted. And so the availability of getting those nutrients available to plants isn't so well. So this is like a number that's given on your cation exchange, from 1 to 50, with 10, 11 being really a perfect place to be, just the right amount of clay, which is our negative charge, and then our minerals are going to be positively charged. And so the ability to hold those together and to have access to them is what we're looking for. So like I said, that little 5% slice of the pie, and that's a perfect pie, by the way, or ideal, I should say. Most farmed and certainly industrial farmed areas are lucky to have 1 or 2% organic matter. And so that's why our focus in restoring is so heavily on this slice of the pie. We need it all, but adding carbon, dead organic matter is carbon, is just so top of the list. Anyway, within this 5%, we're going to find organisms. And even though it's only 10%, you will find that that includes, well, we'll look at that in a second, thousands of pounds of living organisms. Roots our roots are about the same amount, and those roots are in relationship with our organisms. And then humus, which is the carbon, the dead organic matter, the dead biology, is the source that feeds all of this. So soil organic matter is just so important. And 2 of the things that I don't let anybody leave without understanding in my classes are the carbon cycle and the nitrogen cycle, and how this works to create clean air and water and fertile soil. So if we look at the nitrogen cycle, let's start by looking at what's going on in the soil here. The soil biotic community. So we said that's 10% of that 5% of the pie we call soil. And if you look at this, just simply, if we look at the middle part where it says photosynthesis, we see that all these arrows really flow from the organic matter. And that's that humus, that carbon, the dying and rebirth of carbon is what's happening constantly in soil. That organic matter supports the plant life, that supports the larger biology, which includes animals and people. And it also provides the carbon, the solid carbon, that's digested by the microorganisms that are working under the ground. And if you look at these numbers of how much support we're talking about, thousands of pounds altogether of the biology that lives in the soil. So the key is organic matter in the support of this system, from the very smallest to the very largest of organisms. And if we look at the layers, always in the middle, we find the organic matter. Sometimes this is an easier way to understand it when you see the concentric circles around the organic matter. And the thing is, this biology, this microbiology, that is our first level of consumers, and then we get the larger stuff and the even larger stuff as we move away. None of this can survive independent of the other. So we have to first start with the food source, which is the organic matter or the carbon or the humus, and then we bring in the smallest, the microbiology, the things we can't see without a microscope. And then we move to what feeds off of the microbiology, not just off of the biology itself, but off of the poop, sometimes we might just say. And each level builds from the level below it. So a simple soil test you can do is simply to go dig up soil on the 3-inch layer, and students love to do this, and record how many living things you can see. For every living thing you can see, there's probably thousands of ones that you can't. If you're lucky enough to have a strong enough microscope to look at the microscopic life is also awesome. And it gives you a lot of information on your fertility. The more diverse organisms that you have in your soil, the more fertile it's going to be. So just great science around soil. We can introduce the microbiology and the functions of microbiology. We can see them in our compost piles and see them if we have strong enough microscopes, as I mentioned. These are fungal hyphae, and if you have good composting, you'll often see them in your compost pile. Protozoa, some of our more common microbiology, nematodes. Algae is getting into our next level. We can see algae. It's usually located on the top or very close to the top of our soil. And this is a nitrogen fixer. It's not a bad thing. Arthropods, this is where we can start seeing things with our eyes alone. The more diverse our arthropod community is, the more diverse everything else is too. And earthworms are what I consider an indicator species. When you have earthworms, you know that you have all the layers of consumers. And so simply counting earthworms in your dug up soil can be an indicator of where to plant. Wherever you have more earthworms is where your more fertile soil is going to be. Of course, you have to look at other factors too, but yeah. So then these are those functions that I mentioned. The first one being the function of sinking atmospheric carbon. We know that our atmosphere is overburdened with CO2 or carbon dioxide from the burning of fossil fuels. We know that we no longer have enough living organisms to digest that through photosynthesis in the way of plants. Deforestation, of course, is one of the biggest loss of CO2 digestion. And I know we're trying to bring that back, but this is happening in the water. This is happening all over on the land. But when we have plants and we have the ability for them to breathe in this CO2, to digest it of sorts, share it in the ground with our organisms, to create fertility, and then also to give up the oxygen that we so depend on for our own lives. And this is how air is cleaned. So we need to, of course, lessen our burning of fossil fuel to bring down the atmospheric imbalance of greenhouse gases. And we need to also increase the digestion, and that comes from living plants. I do a lot with perennial plants, and the teaching of this concept goes well with that. So then we also have another big function of soil is the nitrogen cycle. We know that we all need nitrogen to live. We know that we have an overabundance of it, probably one of the most abundant in greenhouse gases in the atmosphere. This is also digested by a certain family of plants called legumes. So using legumes, not only because of their ability to clean the air, but their ability to bring nitrogen into the soil in a natural way and to share that nitrogen with the plants around it. It's kind of a system of natural fertilizing, and then also to bring that to the plants and to the food that we eat, because we also have the need for nitrogen, but cannot digest it directly from the air. We have to address our agricultural practices. And once we have a community of consumers who understands this better, which is part of our education in farm and school, then we start to make the choices that become the solution. We look at the world, we're all contributing in different ways and different amounts to the degradation of our soil. In America, our biggest problem is agricultural practices. And so the teaching of regenerative farming is totally in line with understanding the environmental relationship, and also empowering our students to be earth stewards through their consumer choices. And we can talk to the youngest of kids about this, of course, with different amounts of information, but certainly junior high kids are doing a lot of purchasing and consuming of food And I work with university-age young adults as well who are preparing to set up their own homes and environments. And this is all great, empowering information for them. So by managing our soil organic matter, which we go on to work on our own farm, how do we manage organic matter? How do we make more of it? How do we accelerate nature's process of creating fertility? If it takes 100 years to create 1 inch of topsoil in an untouched area, how can we make that happen more quickly? And I think in a lot of the sessions that you will follow in our conference series, you will see that all these farmers are working on this very thing. You'll hear them talking about fertility cycles, about using chickens and manures, about adding compost. These are all ways that we're not only working to grow better food, but to clean the air and the water and to create a sustainable future for our students and our students' families. So this is another great project that was funded by SARE. It's a ecological eaters series of short video clips that are thematic for different things you might be teaching in a farm to school program. I'll share this summary with you of this particular lesson. We can insert it here and finish with that. And you can find these on YouTube.
Soil. It's the foundation of life, the heart of a successful and harmonious ecological farm. Perhaps the single most valuable resource a farmer needs to manage, soil is the byproduct of a millennia of geological processes breaking down and mixing together rock and organic matter.
Really the crux of what we're doing is about soil. And it's this incredible environment of multi-species diversity and all the microlife and all the worms and bugs and everything that come with it. You know, some plants are in their heyday this month and they die back or flower and others come along. So this is a whole process that happens. And that is, that's key.
This rhythmic rotation of life and death is the driver of the carbon cycle, a mechanism by which carbon is exchanged between the atmosphere, biosphere, and hydrosphere.
When we think of restoring the environment, we think about sinking carbon, and it's the living soil that actually digests that carbon. If our soil's not alive, then it doesn't have the ability to do that. So restoration agriculture is grounded in living soil.
If soil is the heart and carbon is the skeleton, then nitrogen is the muscle that moves the circle of life. Invisible to the eye, nitrogen is the most abundant element in the Earth's atmosphere. But before it can be used by plants and pass through the food chain, an unlikely friendship must flourish.
It's a bacteria that's in the soil that associates with the plant, and that bacteria takes nitrogen from the air and sequesters it into a usable form. It has an exchange with the plant where the bacteria forms a colony on the roots called a nodule, and in exchange for sugar from the plant, which the plant has an abundance of, it feeds nitrogen to the plant. So there's a trade going on there.
Soil testing is an invaluable tool for a farmer to analyze the vast, complex network of living and non-living relationships that exist beneath our feet. But not all soil tests are alike.
You can't just give it to a fertilizer dealer and have them test it, because they'll test it for 5 to 12 things. And we need a test for much more, but we need a test for the relationships more than anything. All these nutrients, trace minerals, macro minerals, they're all in relationship to each other. The reason why we will balance soil is because we want to make a very comfortable living for the microbes, because they're the ones that make all the enzymes, that make all the nutrients available to a plant, and then therefore to an animal or to us.
It's a ground-up approach. Healthy soil, healthy plants. Healthy plants, healthy food, people, communities, healthy world.
Also, thank you, Sarah, for supporting this project, and Good Shepherd Montessori School for sharing what we've been growing and doing for 20 years. And we hope that you take away a lot from this conference and that you'll join us in future conferences. So thank you very much.